Hi, this lesson deals all about estimating when we are going to be dividing, and it's a good measure to always estimate before any operation. Today we're going to be focusing on estimating quotients. You should have your notebook ready, as well as the purple note page that I gave you in class. Please fill out your table of contents first. We're on page 13, and we're just going to call it the same as the title of the purple page, Estimating Quotients. Here's a little comic. I happen to love these little humorous math anecdotes. And this one says remainders again, and there's a bunch of division signs looking at leftovers. Just a little humor to get us warmed up to talk about division. So the big vocabulary word of this lesson is the word compatible. So the vocabulary word of the day is compatible numbers. So compatible numbers are numbers that are easy to divide mentally. We want things to be easy for our brain to do without having to pick up a piece of paper and scratch it out. So fill in the word easy to divide mentally. They're often called friendly numbers. And here's a little picture. We go together. There are numbers that are in the same fact family. Well, side note, my wedding day happens to be a fact family, 8715. So we got married, Mr. Trumble and I, on August 7th of 2015. Being a math teacher, I thought that was pretty cool. So friendly numbers, compatible numbers, numbers that go together that you can easily do an operation with, regardless of the operation. Now I'm going to take a little bit of a tangent here. A tangent means you're going in one direction, talking about division. Oh, wait, no, we're going to talk about multiplication for a second. But it is related. The whole point of compatible numbers is to make your life easy, and shortcuts are one of those. An example of working with compatible numbers, 10s. 10 is a really nice number to work with. It's very easy to work with. Powers of 10, just a little bit of review. If you remember, powers of 10 happen to be those little exponents. So, for instance, if you can write down these, this is going along with your note page here. 10 to the third power is the number 1 with 3 zeros to the right of it. That's a positive power of 10. And the opposite, 10 to the negative third power, that's dealing with a small number, still dealing with base 10. We're going to take that 1 and go 3 spots to the left. So, and there's technically a 0 there too. Multiplying by powers of 10 is an easy thing to do if you know the trick, the shortcut. And the decimal point is moving either to the left or right. And you'll do some examples in class over the next day or two to see how that actually works with a calculator, and then practice the trick. So here's the shortcut trick. Again, all in the name of making our lives easier, which is what compatible numbers do. When you're multiplying by a negative power, like 10 to the negative third power, you're dealing with decimals, like 1/10th, 100th, 1,000th, and so on and so forth. Really, all you have to do is move the decimal point to the left, like I showed you in that first example. The same number of places it takes to move from the 1 over to the decimal point. So here's a quick example. If we're going to take the number 55 and multiply it by a power of 10, it could be in that exponential form with the 10 to the negative third, or it could be the decimal, 1,000. The answer is really simple if you know the trick. We're going to start at the 1 and go to the decimal point. And there are 1, 2, 3 hops that it takes to go around the 1, around the 2 zeros. So we're going to take this number and do the same thing. So this is going to equal 55. We're going to go around the 5s, and then 1 more. That's where the decimal will be. So our number is 55 thousandths. A little bit different when you're dealing with positive powers of 10, like 10, 100, 1,000, 10 to the third power is 1,000. Instead of moving to the left, we're going to move to the right. The same number of places it takes to get from the 1 to the decimal point. And this happens to be the same number of zeros as well. And so this is what this looks like. So if we have the decimal now, 55 hundredths, and we're going to be multiplying by a power of 10, like 1,000. There are 3 zeros, and it would take us 3 hops to get from the 1 to the end of this number. So we're going to do the same thing for the decimal. So we're going to take this decimal, and we're going to move to the right 3 places, and we're going to have to annex a 0, making our answer 550. So just a little trick. Deals with multiplication. I know this lesson's all about division, but I just wanted to kind of go off on a tangent and give you those basic tricks for later. Now we're back on track. When we are dividing, we have 3 options. To estimate, we want to do as little as possible. So if we can only manipulate or change one of the numbers, either the dividend or the divisor, that's better than changing both. The more you change a number when you're estimating, the farther it's going to be from the actual answer. You don't want to stray too far from what the real answer is, because the whole point is to make sure your real answer and your estimate are close to each other so you can check yourself. So if you can, the first option is to round the dividend. So for instance, if our problem, and write this down as well, is 61 and 25 hundredths, and we're dividing that by a divisor of 5, there's no decimal here. We're going to try to keep that. So in order to keep that 5, we want a number that works with 5. That's where the compatible numbers come in. What number works with 5 when we're dividing that's close to 61? Well, for our estimate, I'm going to change 61 into 25 hundredths to 60. I'm going to keep the 5, and therefore my estimate's 12. So that's one option. Sometimes you'll have a division problem that you're supposed to estimate, and the divisor is going to be a decimal. So our example for this one could be that 40 is going to be divided by 4.7. Now we only want to change the divisor. So now our estimate is going to be 40 divided by 5, or 8. Now, just a little note here, if you had, for instance, rounded this down to 4 instead of up to 5, you still could have gotten an estimate of 10. Notice 8 is going to be closer to the real answer than 10 would be. So just be careful when you're estimating. There are more than one possible answers depending on how you estimate. The last option is sometimes you're given decimals in both dividend and divisor, and you have to estimate both of those numbers. Again, the more you change it, the less accurate it's going to be, but sometimes we have to manipulate and change both numbers. So this example, we're going to do just 53.7, and we're going to divide that by 2.4. So you notice decimals in both answers. We're going to estimate. I'm just going to label that it's an estimate. That's what I've been doing all along. I'm going to look at these numbers and think which numbers work well together. I know that 50 is close to 53, and I know that 2 will work with 50. So I'm going to, based on my number sense, pick 50 and 2 to get 25. Now, in order for this to be easy, you have to work with your number sense. If your number sense is needing a little bit of brushing up, you need to make sure you're practicing those multiplication facts so this activity doesn't become laborsome. Because if you don't remember that 60 divided by 5 is 12, this is going to be a little bit harder for you. To get us started, you can always use a calculator to help, but we want to make sure we're building up our number sense, okay? The practice problem for you to do on your own, I'm actually going to let you try, and then I'm going to come back and actually walk through this with you because I've stuck estimation into a word problem, and then it's going to ask us to explain at the end. So I want you to just wrestle with it for a little bit, try it, whatever you try, come and bring it to class. You can watch me do the problem afterwards and fix what you need to fix. Again, I want you to really be an integral sixth grader and actually just give it a try before you press play again. So pause and give it a try. So it says that the average weight of a panther is 64 2/10 kilograms. The average weight of a coyote is 14.8 kilograms. About how many times heavier is the panther? And then explain why your answer is reasonable. Let's practice cubes and mark up our problem first. So we need this number and this number. Those are the weights. Those are the important numbers. The key word here is about. You heard me say about kind of obviously when I was reading it out loud. About tells us to estimate how many times heavier. Now that's a key word saying, we're going to be taking something and figuring out how many times heavier it is. But if we're really thinking about what we're given, we're actually going to have to divide. Let's finish cubes, though. I'm getting ahead of myself. This is the question about how many times heavier is the panther. And then this is also something that we're going to have to do. So I'm going to underline it. Explain why your answer is reasonable. Now back to which operation are we picking? It says about how many times heavier is the panther. If we were to multiply these numbers, that wouldn't make sense because we already know how heavy the panther is. But we want to compare the two weights. And we want to take this 14 and figure out how many 14s would we need in order to get to the 64. Now I've dropped off the decimals just for simplicity. So what we really have to do is take this 64.2 and divide it by the weight of the coyote to figure out how many coyotes could you actually put together and make a panther. Basically, if you really want to get technical, we're not going to go splitting panthers up and figuring out how many coyotes can fit inside of them, but you get my idea, hopefully. So now we have a division problem, and now we have to estimate because it says about. So 64.2 and 14.8. We have to think about numbers that work well together that are close to that. That's where the compatible friendly numbers comes in. So if I were to look at this number, I would say this is close to 60 and this is close to 15. Now let's think, is this a friendly fact family? And it actually is, because 15 and 15 is 30, and then if you do that another 2 times, that will be 60. So I just mentally figured out 60 divided by 15 is 4. Now with the explanation part. Whenever you see the word explain, you need to write something of an explanation of a sentence. So here's an example of what you could write. There are lots of different ways to say this. So the answer is, there's only really one way to say this, but you could vary it a little. So the panther is 4 times heavier than the coyote. You want to answer the question first. How many times heavier? 4 times heavier. Okay. Now, here's the explanation. Since is a nice word that kind of just is an introductory word that starts off your explanation. Since 4 times 15 equals 60, and all I really did is I reordered the fact family. I have 60 divided by 15 is 4. Now I just changed it around. Since 4 times 15 is 60, and 60 is about, there's my estimating word, 64.2, so I've just shown that 60 is close to 64.2. My answer, or the answer, you could also say, the answer is reasonable. And again, the word reasonable just means, does your answer make sense? My answer makes sense because 64.2 is close to 60, and 15 could even go even farther and explain that 15 is close to 14.8. Again, there's a little bit of variation here on how you explain it. Tomorrow in class, we're going to do just estimating quotients. Sometimes they'll be, let's explain why, and sometimes it'll just be, let's just practice estimating with our number sense. See you tomorrow.